Anyone know? What can't go under a root symbol? Yeah. Negative. Can a 0? Can we square root 0? Square root of 0 is 0. You can root 0. Okay? But you can't square root negative numbers. We agree? Okay. So when we're looking at this basic function here, which I told you, oh, good, it didn't show up. Awesome. I'll write it out. So we have y equals root x here in the notes in front of your face. We agree? Now, press graph, and look at your graph in front of you. Where is it starting at for the x? What's the domain? Greater than or equal to what? 0. We agree? Well, it also stipulates because of this. What x values? I have a square root of x, right? What do my x values have to be in order for this to work? Well, they have to be, x has to be greater than or equal to 0. We agree? That's a true statement, isn't it? Because we can't have negatives under our root. So that's where the graph is starting there, because that's where it has to start. Okay? So we know it starts at 0, 0. This is the parent function, the function before it has been transformed. We're going to talk about transformations again today. Transformations never leave, just so you know they're in every unit. So 0, 0 is, I'm going to use a different color. 0, 0 is where it first starts. And then we could go to our table of values. We could go second graph and pull off values. Or you can make a table of values like you were taught to do in grade 10. So we have an x, y, t table. Y happens to be root of x, correct? So if x is 0, y is the root of 0, which is 0. If x is 1, y is the root of 1, which is 1. X is 2, it's root 2. That's a decimal, right? So I don't want that one. Root 3. Could you draw decimals? Sure. Go ahead. The more points you put on a graph, the more accurate it is, correct? But you're going to see that often it's 4 because the square root of 4 is 2, and then 9 because the square root of 9 is 3, and that's usually the ones that they pick. Okay? I'm going to go x scale 1, y scale 1. So I have 0, 0, 1, 1, 4, 2, 9, 3. So we can get our domain from the actual function. What's underneath the square root, right? We can get the domain from there. The range, you kind of have to look at the graph. So where does your range start here? 0 and above. So we're going to go state the domain and range. So here it says here, we'll do this transformations. Well, we don't have any transformations to state, right? This is the parent function. We've sketched it, state the transformation, state the domain and range. So 3. The domain was x such that x is greater than or equal to 0, xer. Now I want to do it in interval notation. Interval notation is often easier to do if you just draw yourself a little number line. So we have a 0, we have a closed dot, and it's greater than, so it's this way. What does this arrow that I'm bolding represent? Positive infinity. So I have a square bracket on the 0 because it's equal to, and a round bracket on the infinity because you can't be equal to it. You have to be able to do both forms because I can ask you for set notation, which is the one that you can do the set of, or interval notation, which is between two intervals. Okay, the range you told me was y is greater than or equal to 0, which is right. Which is actually the same interval. Square bracket 0, infinity. And it wants the x and y intercepts. What's the x-intercept at? X-intercept 0, 0, and the y-intercept is 0, 0. And there are no transformations because it's a parent function. Then we're going to look at y equals the square root of x minus 2. What do I know about what's underneath the radical? It has to be what?
Greater than or equal to 0.
Yeah, it has to be greater than or equal to 0. It has to be positive or equal to 0. Yes. So we know, here's our function, y equals square root x minus 2. we know that x minus 2 has to be greater than or equal to 0, correct? Is that not a true statement? When's the only time an inequality sign flips?
When you flip it.
But how? What has to happen? Nope. That would happen if you moved something to the other side. I'll agree with that. But when does the actual inequality sign flip itself? Anyone remember? You divide by a negative. If you divide, then speak up, girl. You divide by a negative, the inequality sign flips. We agree? Keeping all the knowledge over there, but not sharing it with others. Rude. Okay. So when you divide by a negative, your inequality sign flips. We agree? So what am I going to do here to get x by itself? I'm just going to add 2. Would my inequality sign flip? No. It's only if I divide by a negative. So I add 2, and now I know that x has to be greater than or equal to 2, which makes sense based on the transformations. What's the only transformation that's happened in B? Horizontal translation to right. We agree? So if I take this entire graph here and I move it to right, it's just going to change my domain to be greater than or equal to 2. Will it affect my range at all? Will it change my range at all? No, it'll still be greater than or equal to 0. So we can just move this one 2 to the right. So I can go 0, 0 is now going to be 0, 2. 1, 1 is now going to be 3, 1. 4, 2 is now going to be 6, 2. 9, 3 is now going to be 11, 3. What's the only thing that's going to change my domain? You just said dividing by a negative. We agree? What is that in transformations? It's a reflection. So when we have a reflection in the y-axis, your graph is going to go from x is greater than or equal to something to x is less than or equal to negative something. Right? Okay. So this one, my domain, is x such that x is greater than or equal to 2 xer, which in interval notation is a square bracket 2 to infinity. And my range is y such that y is greater than or equal to 0 because nothing happened to my y's. So the range isn't going to change. So 0 to infinity. What's my x-intercept at? I'm going to write it here. X-intercept is at 2, 0. My y-intercept does not exist. And what's the transformations? Horizontal translation, 2 units right, yeah. Could I have just typed square root x minus 2 into my calculator and gone to the table of values and all that jazz and drawn it that way? Yeah, totally could have. But I don't want you to do anything other than, for C and D, you might need a separate sheet of paper to write like the transformations and stuff out because there's not a lot of room in there. But, and if you need extra paper, there's some up here and I have extra stuff over there too. So if you need an extra piece of paper, come grab it. But what I want you to do for C and D, just only for C and D for now, is I want you to state the transformations and sketch the new graph using mapping. What graph am I going to put in the input points from? What graph am I going to use its original points to map with? This one, the y equals root x, the parent function. Okay? So you probably need a separate sheet of paper. There's not enough room. If you don't have paper, you can come grab some from here. I also have a stack over there. Okay, I want you to, I don't want domain and range right now. I don't want x and y intercepts right now. All I want you to do is graph the function from the parent function and state transformations. Make sure you're using pencil. One thing I want to give you a little heads up on is this equation is y equals 3 square root Negative x plus 1. What must I do before I start doing anything? Yeah. So I need to take the negative 1 out to make sure I have a positive 1x. So I'm going to get y equals 3 root negative 1 x minus 1. So it's actually 1 to the right, correct? I'm going to help you with the next one too, because this is the trickier one. The next one is y equals negative 2 square root 1/2 x minus 4 plus 3. What do I have to take out? A half. When I take out a fraction, it actually makes the other number bigger, because you're dividing by a half, and when you divide by a half, that's actually like multiplying by 2. So when you take this GCF of a half out, this number will always get bigger. If you take a whole number out, like 2, 3, 4, 5, this number will get smaller. If you take a half out, this number will get bigger. I promise you. If you're like, I suck at that, use your calculator. It's expensive. Get some use out of it. Go 4 divided by, in brackets, a half. It will tell you it's 8. Okay? So this is going to become y equals negative 2 root 1/2 x minus 8 plus 3. So try those two out. I want you to use mapping, and I want you to state transformations. So the first thing we'll do is state transformations. We have to start with stretches, then reflections, then translations. So this first one, we have a vertical stretch, because it's outside. Vertical stretch. If you're still like, I don't know if it's horizontal or vertical. I don't know if I flip it or I don't flip. I don't know. I'm afraid for you. Please study. You have to know them backwards and forwards. You need to see that 3 outside and be like, vertical. Oh, the negative 1, reflection in the y. Oh, it's an x minus 1. Oh, okay, horizontal translation 1 right. Like, it must just be like, you see, you know, you see, you know, you see, you know. If there's any like, maybe, x, y, that is a scary place to be writing this test in. Like, I don't know how else to say it. Every single common error is there, right? So if you don't know your stuff backwards and forwards, you're going to pick a common error. It's just the way it's going to be. So know your stuff. Vertical stretch by a factor of 3 about the x-axis. The negative in under the brackets is with the x, because I could distribute it in, and if I could distribute it in, it's with the x. So it's a reflection in the y-axis. And then that 1 is a horizontal translation, 1 what? Yeah, horizontal translation, 1 unit right. So if I use these, what's my mapping? X, y becomes, now it's a vertical stretch by a factor of 3, so that affects my y. 3y. It's also the only thing that affects my y's, because it's the only thing out here and here, right? And these affect my x's. So I'm going to minus 1 from my x, and I'm going to add 1. I'm going to multiply my x by negative 1, and then I'm going to add 1. That's what I meant to say. So negative x, add 1. So then we're going to need mapping. So we have the original coordinates are 0, 0, 1, 1, 4, 2, 9, 3. So I'm not making my x scale or my y scale until I've actually found out what the new points are, correct? But could I have just, because that one didn't have an f, those equations don't have f's in them, do they? They're just something, square root, something, correct? Could I not just plug them in my calculator? And just go second table and get some points and graph it? Yes. The only time you can't type it into your calculator is if it has an f. There's that little f in the middle, because that's just transformations. That's telling you, hey, move it this and do this with it and do that with it. But if there's no f, you could have just typed it in. But we're just practicing our mapping. So we're going to go negative 0 plus 1, comma 3 times 0. Oh, it's 1 and 0. So that's my new point. This one is going to be negative 1 plus 1, comma 3 times 1, which is 0 and 3. This one is negative 4 plus 1, comma 3 times 2. So it's negative 3 and 6. And then negative 9 plus 1, comma 3 times 3 is negative 8 and 9. So the standard window will fit those, right? Your standard window will fit it. So you can just do x scale of 1, y scale of 1. So I'm going to plot 1, 0, 0, 3. Why is it going this way? What the heck's happening here? Why is it heading that direction? What's happening? What transformation would cause it to go the other way? It's a reflection in the y, right? So instead of going this way, it's making it go that way. Okay, so that makes us feel better. Negative 3, 6, negative 8, 9. Three, 4, 5, 6, 7, 8. Yep. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. What's my domain? I didn't ask you this, but now I am. What's my domain? Let's pretend that went through the dots. No. But shit on test. X has to be what? X is less than or equal to 1. XER. And then less than or equal to 1 means if this is 1, that is a 0. What am I doing? Scare me sometimes. 1, and it's less than. This is negative infinity. So it's going to be negative infinity to 1. Did my range change? No, because my y is 0, and all I did was multiply it by 3. And when I multiply a 0 by 3, it stays the same, right? So the only thing that's actually going to move that range up or down is a vertical translation. So it's going to be y such that y is greater than or equal to 0. Okay. We're going to look at this one. This one has a vertical stretch by a factor of 2 about the x-axis and a horizontal stretch by a factor of 2 about the y-axis, because your horizontal stretch always flips, always flips. If you're like, I can't remember that, you need to study it. Okay? You need to know. So we have a vertical stretch by a factor of about the x-axis, and a horizontal stretch by a factor of 2 about the y-axis. Are there any negatives? Yeah, there's a negative in front with the y, so it's a reflection in the x. I don't know what's going on. And then this is a horizontal translation, 8 to the 8 units right, and a vertical translation, 3 units up. Why I capitalized, right? What is it? Vertical translation. What was it? Vertical translation. 3?
Yeah.
Up. So anything that affects the vertical affects the y, anything that affects the horizontal affects the x. So we're going to get x, y, stretches and reflections multiply. So I have a vertical stretch by a factor of 2. So I know I'm going to get 2y. Horizontal stretch by a factor of 2. I know I'm going to get 2x. Reflection in the x means my y is negative. 8 units right. How do I move right? I add 8. How do I move up? I add 3. Remember, words and mapping are the same. Words and mapping are the same. If you're going right, you have to add. If you're going up, you have to add. Then we plug in our original points. 0, 0, 1, 1, 4, 2, 9, 3. So we're going to get 2 times 0 plus 8, negative 2 times 0 plus 3. And my new point is at 8, 3. So that's where this graph is starting. Now I know that there's a reflection in the x, so normally it's like up and to the right. It's now going to be down and to the right. It's still going to be to the right because it didn't reflect in the y, correct? But now it's going to be down because there's a reflection in the x-axis. So we have 2 times 1 plus 8, comma negative 2 times 1 plus 3, which is 10 and 1. And we have 2 times 4 plus 8, comma negative 2 times 2 plus 3 is 16 and negative 1. And then we get 2 times 9 plus 8, comma negative 2 times 3 plus 3 is 18 plus 8, 26. And negative 3. So x scale of 1 is out, right? If you do an x scale of 1, if you're doing this, sorry, but this happens, so I'm going to be blunt. This is the screen of which I give you. Okay? And you don't change your scale. So your graph looks like this. And you're like, there's like all this graph, but your graph is drawn off the graph, Talendor. I'm assuming it's you. You have one point actually on the Cartesian plane and the rest of your points are randomly off on white space? No. Bad.
I have 2 points.
Still bad. Better, but still bad. And I promise you, you're not alone. I would take your scale of 3 in this instance. Yes, yes, I would. Okay, so I need to fit 26, right? So a scale of 3 is actually very appropriate. 4 is even, but do most of them fit on it?
You can fit 2 of your points.
You can fit 2. I'll agree with you. Sure, we'll go with you. Okay, so x scale of 4, y scale 1. Because I don't need to change my y scale. They're little numbers. So we have 8 and 3. Now to remember, left, 4. Your x scale is 4. It's 4. I swear, it's 4. Okay. 8 and 3. You may laugh, but you drop off the scale very quickly. So 8 and 3. And then we need 10 and 1. So that's halfway. 10 and 1. Wait, it's going downwards. What's up?
You're 8 and 3, it's 8 and 2. Or
No.
That's 8 and 3.
2.
I'm wrong often, but not this time, so we'll move on. Okay, 10, 1, 16 and negative 1. Uh, 26 and negative 3. boy. Pretend that's straight. I might have to keep moving straight. On this board, it's a little hard to trust. So remember, you're just sketching these points. 26 falls between two of them because I made an x scale of 4. Okay, we're going to flip over. Now I give you a graph. You need to give me an equation. So it says an equation in the form y equals a square root b x minus h plus k. Now, I told you, yeah. Yes. So I told you that the only thing that affects that starting point is horizontal and vertical translation. Do you agree? Your starting point normally is at 0, 0, correct? So if I actually have a reflection, I'm multiplying by -1. Does 0 change when you multiply by -1? No. If I have stretches, like 2 or something like that, if I multiply those zeros by 2, does it change it? No. So the great thing about radical graphs is that they normally start at 0, 0. If they're not at 0, 0, you instantly have the vertical and horizontal translation. This is the only graph that you can find the vertical and horizontal translation right away. So if that starting point is not there, go find out where it is, and that's your horizontal and vertical translations. Those are the easiest things to find. Okay? Only with radical graphs can you do that. So this graph actually now starts at -3 and 4. -3, 4. So if I go to statement of transformations, I have stretch, reflect, translate. I have the translations first, which I never, ever, ever, ever normally can get right away because you usually have to do your stretches and reflections first, correct? But I can get my translations right away because the stretch and the reflect won't move that point because there's 0, 0. When you multiply 0 by anything, which is what stretches and reflections do, it's not going to change it. So what are my translations? I have a horizontal translation. It was at 0, 0. It's now at -3, 4. I have a horizontal translation. 3 units what? Left. Because I was at 0, 0, I'm now at -3. Right? And a vertical translation. Four units left. So I actually have the h and the k. I have this part. X minus, or x plus 3. And then plus 4. Those pieces are done. We agree? Does everyone agree to that point? Okay. B, C, and D. Get me the H and the K. We'll do the rest after. I want to solidify this. Go figure out what the translations are. Give me my H and my K. H, my K, H, my K. Go. You're being your seat. Oh gosh, I do this. B, C, D. For B, it's a horizontal translation, 5 units left. Vertical translation, 3 units down. So y equals x plus 5 minus 3. This one, it's at negative, or 5 and -1. So I know that I have a horizontal translation 5 units right, a vertical translation 1 unit down. So I'm going to get x minus 5 minus 1. And then this one is at 4 and 5. So I'm going to have y equals x minus 4 and then x plus 5. Okay. Everyone understands that spot? Yeah.
How do you know what point to use?
The starting point. The other one has an arrow.
You have to use starting point?
Yeah. Because it's where your starting point moves. And your starting point normally is at 0, 0, correct?
Yeah.
So now wherever it moves is where your horizontal and vertical are. Okay. So, The next thing to note about this is let's do reflections next. Okay? Normally it's up and to the right. We agree? The basic radical function is up and to the right. So if it's not up and to the right, a reflection has happened. We agree? So let's look here. This first one, is it up and to the right? No. It's down and to the right. So which way did I reflect? Did I reflect? I reflected on the x-axis, right? So if it's down, it's reflected in the x. It was up here, it's now down here. So it's a reflection in the x. So where's the negative with? The y. Is this one up and to the right? Yeah. So are there any reflections? No. Up and to the right. No reflections. This one is up, but it's to the left. It's supposed to be up and to the right. It's now to the left. Where did I reflect on? The y-axis, which means the negatives with the x. Is this up and to the right? No, it's actually complete opposite. It's down and to the left. So they're both negative. Okay. Now the stretch that I do, I figure out the stretch based off of which one's easier. So when we do our basic function, it's at 0, 0, 1, 1, 4, 2, etc. Correct? The key thing to look here, though, is that the first two bullets, or the first two coordinates, make a 1 by 1 box. We agree? So if between your first two coordinates you do not have a 1 by 1 box, it is stretched, vertically or horizontally. Okay? So I'm going to go between, so I'm going to just erase that. I don't know what I just erased. Something somewhere. Okay. So instead of a 1 by 1 box, let's draw this one out. It's going to be not a 1 by 1 box. Oops, got a little aggressive. It's a 1, 2, 3, 4, 5 by 1 box. We agree? So which way did it get? Wider or taller? Wider. Horizontally or vertically? Horizontally. I just went between the 2 points here and made a box, guys. It's normally a 1 by 1 box. It's now a 5 by 1 box. So it's horizontally stretched by a factor of what? 5. So if I go, do I put a 5 right here? Horizontally stretched by a factor of 5. Do I put a 5 here?
1/5.
I put a 1/5. Yeah.
I'm confused because, like, when you were doing it from the original function, it was the first 2 points.
This is the first 2 points. Oh my goodness. What did I do?
was so confused.
Oh my gosh.
That deserves a Lepp. Used to.
I just deserve a Leppy buck taken away at that point. That's not a Leppy buck. Oh, there's no stretches. Moving on. Okay, good talk. That one, nothing happened. Let's go to this one.
Oh.
That one has no stretch. Oops. This one is a what? Okay. Were you saying a quarter? Aggressively? Okay. So this one horizontally stretches by 4, so it would be a quarter. That is true. What about this one? Oh, by 2. So where does it go? In front or with the negative sign? Thank goodness, because there's no space. That was unintentional. No space left. And then this one. Vertical by 4. I'm gonna do 4. Okay? We're going to come back to this, but I'm going to get you to do the homework questions out of the textbook on this particular question before it falls out of your head. Page 99, number 7. So in here it says, write the equation of a radical function with each domain and range. So the domain is x such that x is greater than or equal to 5, xer. And the range is y such that y is less than or equal to 2, yer. So the way to help myself out with these ones is I always will do a kind of a little sketch. So I know 5, 2 is where this graph is starting, correct? It's starting on 5 for the x, it's starting on 2 for the y. You can see that because it's 5, 2, correct? Which means those are the horizontal and vertical translations. We agree? Because where the graph starts is the horizontal and vertical translations. So I'm going to go and plot 5, 2, because I'm going to give myself a little sketch because it makes it easier for me. 1, 2, 3, 4, 5, and 2. Now I know it needs to be greater than 5 and less than 2. So I'm going to go up to be greater, to the right to be greater than 5, but I'm actually going to go down to be less than 2. So I'm going to go like this. It's going to be something like that. Could it be steeper? Sure. It doesn't matter.
That's off the graph.
This is a sketch for myself. -3 Leppy bucks per pound. You want to do homework checks.
We're just driving, being negative.
Here, Dory. Okay, so we have, from these values, we have the h and the k. We agree? So we're going to go y equals, and then I'm going to go x what? X minus 5, and then plus 2. We don't have to worry about the vertical or horizontal stretches at this point because we don't actually know what the graph looks like. We're just doing basic minimum, bare minimum, how I can get an equation. So the stretches I don't have to worry about, but the reflections I do. Is this one up and to the right? No? It's down and to the right. So where's the reflection? Instead of being up, it's now down. What am I reflecting on? The x-axis. So where does the negative go? With the y. Goes there. You try B. And then we're going to 4. B is x is less than or equal to -2. Y is greater than or equal to -4. So -2, -4 is where it's going to start. Just let me draw this large so I can stay on the whole entire graph. Checking the phones out. A lot of phones. -2, -4. And then I want to be less than -2, so I need to go to the left, and greater than -4, so I need to go up and to the left. Boom. Look at how much of that graph's on the graph.
All of it.
All of it. Mad skills here. Mad skills. Okay. So I know that it's going to be y equals x plus 2 minus 4. And it's not up and to the right, but it is up and to the left. So there's only one reflection, because if it says up and to the right, up and to the left, one thing only changed, right? So if it's right, it's to the left. It's now reflected in the y, which means the negative is with the x. Boom shakalaka. Okay, flip over. Number 4. I'm going to get you to try it on your own, because you shouldn't need my help. Write the radical function that results from applying each of the transformations to the graph of y equals root x is what that should say. There should be a little root symbol. Put a little root symbol on that x. Put the little root symbol on the x.
It's not better.
Girl, please. Put the root symbol on the x. Okay. A, B, C, D. Go. Apply the transformations to the equation. Do it. So, words and mapping are the same, but when you go back to the equation, your horizontals flip, correct? But your verticals will always stay the same. So here we have vertical stretch by a factor of 3 about the x-axis. Reflection in the x-axis means it's a -3 root. 4 units right, so x minus 4, 2 units down, minus 2. If you're still erasing and putting them in different spots, I once again hazard you to study. Please. Finish stuff backwards and forwards. So we have a horizontal stretch by a factor of 1/4 Horizontal stretches always flip when they go from words into equation. Words mapping same, words to equation flip. About the x-axis reflection, or in the y-axis, reflection in the y-axis. Translation 3 units up. And 5 units left. C, we have a vertical stretch by a factor of 2. Horizontal stretch by a factor of 3, so I get a third. Translation 1 unit up, 4 units left. D, vertical stretch by a factor of 3. Horizontal stretch by a factor of 1/2. Reflection in the x-axis and the y-axis. Translation 6 units left. And your homework. Previous to this, I said page 99, number 7. I'm just rewriting it. Should be already done it. And then page 73, number 4, which is matching. 5 ABD and 11.